Solve the equations using the row echelon method. We're given the system of equations x plus y plus z equals 6, 3x minus 2y plus 3z equals negative 7, and 4x minus 2y plus z is equal to negative 12. Our first step will be to translate this system of equations into an augmented matrix. So the first row would be 1x plus 1y plus 1z is equal to 6. Row 2, 3x minus 2y plus 3z equals negative 7. And the final row, 4x minus 2y plus 1z is equal to negative 12. So there is our original system of equations written as an augmented matrix. So now we'll row reduce the left side. And the first step is already taken care of. We need the upper left-hand corner to be a 1, and now we'll use that 1 to make the rest of its column 0. So we need a 0 in this position and a 0 in the bottom left corner position. So we can do two row operations at one time. We're going to take negative 3 times row 1, add it to row 2 to get a new row 2. And we'll also take negative 4 times row 1, add it to row 3 to get a new row 3. So row 2 will change, row 3 will change, implying that row 1 will not change. So recopying row 1, we have 1, 1, 1, 6. Our new row 2 will be negative 3 times 1 is negative 3, plus 3, 0. Negative 3 times positive 1, negative 3, plus negative 2 is negative 5. Negative 3 times 1, negative 3, plus 3, 0. And negative 3 times 6, negative 18. And plus negative 7, negative 25. Now we'll take negative 4 times row 1, add it to row 3 to get a new row 3. Negative 4 times 1, negative 4, plus 4, 0. Negative 4 times 1, negative 4, plus negative 2 is negative 6. Negative 4 times 1, negative 4, plus 1 is negative 3. And negative 4 times 6, negative 24, plus negative 12 is negative 36. So there's our augmented matrix after these two row operations. Our next task will be to get 1s on the main diagonal, so let's get this middle position to be a positive 1. So we're going to multiply this whole row, row 2, by negative 1/5. So negative 1/5 times row 2 to create a new row 2. So that means rows 1 and 3 will not change. Row 1 will be 1, 1, 1, 6. And row 3 will remain 0, negative 6, negative 3, negative 36. However, we're going to multiply row 2 by negative 1/5. 0 times negative 1/5 is 0. Negative 5 times negative 1/5, positive 1. Negative 1/5 times 0 is 0. And negative 1/5 times negative 25 is positive 5. So there's our augmented matrix after that row operation. We will now use this 1 to cause this position to become a 0. So we're going to take 6 times row 2, 6 times row 2, add it to row 3 to get a new row 3. Therefore, rows 1 and 2 will not change. Row 1 will stay 1, 1, 1, 6, and row 2 will stay 0, 1, 0, 5. And now we'll take 6 times 0, which is 0, plus 0 is 0. 6 times 1 is 6, plus negative 6 is 0. 6 times 0 is 0, plus negative 3 is negative 3. And 6 times 5 is 30, plus negative 36 is a negative 6. Let's now go ahead and get a 1 in the bottom right-hand corner of the left side of our augmented matrix. So we're going to multiply row 3 by negative 1/3. So negative 1/3 times row 3 to get a new row 3. So rows 1 and 2 will not change. Row 1 stays 1, 1, 1, 6. Row 2 will stay 0, 1, 0, 5. And now negative 1/3 times row 3 gives us 0, 0, 1. And negative 1/3 times negative 6, positive 2. And as you can see here with our current augmented matrix, the second row and the third row implies that 1y equals 5 and 1z equals 2. So we know 2 out of our 3 variables. So let's take this augmented matrix and translate it back into a system of equations. So row 1 gives us 1x plus 1y plus 1z is equal to 6. Row 2 gives us the fact that y is equal to 5, and row 3 gives us that 1z is equal to 2. So we know 2 out of the 3 variables. We will now substitute our y value and our z value into the top equation to help us to get x. So substituting 5 in for y and 2 in for z gives us x plus 5 plus z is 2. That is equal to 6. 5 plus 2 is 7. Subtracting 7 from both sides implies that x has to equal negative 1. So the solution to this system of equations using the echelon method gives us xyz being negative 1, comma 5, comma 2.